if you're tracking the operationalization of AI, and for our audience of executives and researchers, that's really where all the leverage is right now,
Yeah.
then, we are way past the simple chat phase.
Oh, completely.
We're officially decoding what we're calling the agentic horizon. This isn't about models that just, politely answer your questions anymore.
Oh, not at all.
This is about models that do things,
Yeah.
that execute complex, multi-step workflows, and that are fundamentally changing the cost structure of entire industries.
That is the crucial distinction. The signal is, it's deafening right now. And what all our sources are showing is this definitive, very sharp bifurcation in the landscape.
Bifurcation. How so?
Well, we're seeing intense specialization become the dominant strategy. You have Flash, which is optimized purely for speed and throughput.
Right.
You have Opus, which is all about verifiable, high-stake safety. And then you have Llama, which is still pushing that raw parameter scale for the open source world.
So the pivot is complete.
It is. The central question in the C-suite is no longer how smart is the model on a benchmark. It's now how effectively and how efficiently is this model integrated into my workflow to deliver, a measurable ROI.
Okay, so let's unpack this. Our mission today is to go deep on exactly that bifurcation. We're going to analyze the newest frontier model drops, the surprising rise of efficiency, and this idea of sovereign AI.
And the bottlenecks. We can't forget those.
The brutal, non-negotiable infrastructure bottlenecks. And trust me, we are talking geopolitics and a sudden critical shortage of megawatts. And finally, the critical societal friction points that are now becoming urgent liability lawsuits. It is definitely time to stop talking about potential in the abstract and start talking about what is actually in production today.
Let's do it.
All right, let's start with the giants and how they're defining this shift from simple reasoning to, complex action and integration. The proprietary arms race is now a fight for throughput, for sub-second execution.
And Google just threw down a massive gauntlet, using optimization as its weapon.
Their move with Gemini 3 Flash, it's a perfect example.
It's a textbook execution of that strategy we just talked about. Speed is the new scale. This is a model that is optimized for extreme speed and significantly lower latency.
Which means it's purpose-built for those high-throughput workflows that simply cannot tolerate waiting.
Exactly. Real-time fraud detection, instant customer service routing, rapid decision-making engines, things that need to happen now.
And crucially, it's not some, experimental API tucked away on Vertex AI.
No, it's everywhere. It's powering the Gemini consumer app. It's running search's critical AI mode. It's embedded across their developer tools.
But when you factor in the sheer volume of search users, we're talking billions potentially. This is now arguably the most widely deployed AI model on the planet.
By sheer volume of traffic, absolutely. They are betting that ubiquity, enabled by that speed, wins the day.
They absolutely are.
And the technical achievement here is, I think, worth dwelling on for a moment because it really explains the magic. They got this efficiency through a process they're calling flash distillation.
Right. The teacher-student model idea.
Exactly. So think of it this way. You have the enormous resource-intensive full Gemini 3 model, that's the teacher, and they have successfully transferred 95% of its hard-won knowledge into a much more compact student model.
And the result of that is?
The net result is a 40% reduction in size.
That is a staggering efficiency gain. That sort of defies the traditional scaling laws. You're telling me they cut the size nearly in half but kept almost all of the capability.
Correct. And that is coupled with an engineering focus that delivers a 2x speed up in response times.
Wow.
And developers are still getting those massive 1 million token contexts, but they're enabled by these specialized sparse attention mechanisms.
Okay, that's a key piece of jargon. Let's break that down for everyone listening.
Right. So traditional models have to read every single token, every word in that massive context, every single time they generate a new word. It's computationally brutal.
Inefficient.
Very. Sparse attention lets the model selectively focus only on the most relevant parts of that huge document, just ignoring the noise. It's like being able to instantly skim a 500-page book and only reading the 5 most crucial paragraphs.
Which dramatically cuts down on the compute load for each inference.
Precisely.
So what does that 40% size reduction and the sparse attention actually mean for the enterprise users, for the developers who are running these large-scale agent fleets?
It means they're aiming to slash their operational costs by 40 to 60%. This is the ROI lever.
This is the number that matters.
This is it. For any enterprise needing sub-second real-time responses, automated stock trading, complex manufacturing floor controls, the preference is shifting entirely to instant and good enough.
So Gemini 3 Flash Makes frontier AI feasible for the masses.
It solves the latency and the cost problem at the same time. It makes that agent loop, the ability for an AI to complete a task, check the result, and iterate instantly, actually viable at scale, where before the cost of a delay was just too high.
So while Google is really pushing on efficiency, OpenAI is trying to cement its lead in raw capability with a dual drop. It's about reasoning and creation, and it's all highlighted by GPT 5.2.
Right. Their core focus now is on truly actionable agents.
That's where the narrative shifts from just speed back to depth.
Exactly. GPT 5.2 thinking is all about general intelligence and instruction following. And the sources are emphasizing that the key capabilities are really designed to solve these high-friction engineering problems.
Like what?
Well, we're seeing a really significant push in front-end UI creation. The model is generating complex functional user interfaces directly from prompts with a much higher fidelity than before. It's moving way beyond simple mockups into usable code.
And the truly critical agent feature, the thing that stood out to me was the update to their autonomous research agents, the deep research agents.
Yes, we are moving beyond simple one-off tool use and into multi-hour self-management.
The 2025 version has an asynchronous task manager. That is a huge conceptual leap.
It fundamentally changes the user expectation. That asynchronous manager lets the AI work on a problem for hours without you constantly having to supervise it.
So it's not just answering a question, it's managing a project.
Exactly. It plans multi-step research iterations, it browses documents, it generates PhD-level reports autonomously. Before, you had to constantly prompt and reprompt the model. Now, you give it the thesis, and the agent just manages the entire execution timeline itself.
That is a direct challenge to human knowledge workers.
A massive one.
And for developers specifically, they got their own focus drop, GPT 5.2 Codex.
Yeah, Codex is a pure developer play. It's tuned for autonomous functions like submitting pull requests, identifying vulnerabilities.
So the goal here is pretty aggressive. They want to replace the co-pilot assistant paradigm with an autopilot agent paradigm.
That's the goal. It's designed to be dropped directly into CI/CD pipelines to self-heal broken builds. If a test fails, Codex doesn't just suggest a fix, it implements the fix and submits the PR for review.
OpenAI is trying to lock in the entire engineering workforce before anyone else can create an alternative.
Aggressively.
Okay, on the creative side, they pushed out the Image 1.5 update.
Correct.
You've seen a ton of generative art, but this update seems focused purely on, production utility.
Yeah.
Professional workflow.
It is entirely about granular control and speed. It's got 4x faster generation. And the key feature for professional designers is these pixel-precise edits that preserve the original composition.
Along with better text rendering, which has always been a problem.
Dramatically superior text rendering. This shifts the focus from the wow factor of generation, which Midjourney has just excelled at, to the production-ready and necessity of control and brand consistency that, say, an Adobe user demands.
Now, let's talk strategy, because maybe the most significant move from OpenAI in the last 48 hours is about IP and data. Their landmark 3-year deal with Disney.
This is a major coup. It proactively addresses the looming industry-wide copyright crisis.
Right.
The deal is really twofold. Disney will use Sora for short-form video and internal storyboarding, which accelerates their content pipeline. But crucially, this grants OpenAI legal licensed access to Marvel, Pixar, and Star Wars IP for training its models, especially Sora.
So they are essentially creating a clean data set, a legally safe one.
Exactly. This lets them generate derivative content without hitting an immediate copyright lawsuit, which is paralyzing other players. It validates the licensed data path over the legal gamble of fair use.
And it buys them the biggest rights holder moat in the room.
It's an advantage that is almost impossible to replicate if you don't have that deal.
Okay, so we've seen the speed race and the capability race. But where's the responsibility in all this? That brings us directly to Anthropic, who are providing the counter-narrative by prioritizing verifiable safety with Claude 4 Opus.
They're trying to build the engine with the strongest brakes.
Right.
Claude 4 Opus is the safety-first reasoning monster. It crushes complex reasoning tasks while deepening its constitutional AI principles, those rules it follows to avoid harmful output.
And it's using advanced interpretability techniques to do that.
Yeah, specifically sparse autoencoders, which is another critical technical detail we should touch on.
Okay, what do they do?
These autoencoders allow for a mechanistic understanding of the model's internal activations. So instead of just seeing what the model outputs, researchers can see how the model is internally processing a request, which neurons are firing, before it generates a response.
It's like having an X-ray into the model's brain.
That's a great way to put it.
But what are the performance metrics? Can it actually compete on capability?
It can. It's getting new state-of-the-art results on crucial agentic benchmarks like GAIA and WebArena, so it excels at multi-step planning.
Okay.
It also has native 2 million plus token contexts and refined harmlessness classifiers that actually reduce those annoying refusal rates. Critically, it shows 50% fewer jailbreaks.
So users can't easily manipulate it into generating bad content.
Right. It challenges that old assumption that you have to trade capability for alignment.
So the implication here is pretty profound. Its transparency tools, those neuron-level explanations, could become the gold standard for high-stakes operations.
Absolutely. Think about regulated industries. Legal discovery, financial modeling, pharma R&D. These sectors demand transparency.
They demand an audit trail.
Precisely. If Anthropic can provide verifiable, neuron-level explanations for why an agent took a specific action, that's going to accelerate adoption dramatically. It forces the black box competitors to seriously rethink that safety versus capability trade-off.
Because for an executive in a regulated field, the black box risk is a liability nightmare.
And the Anthropic approach is a competitive advantage.
Finally, we can't talk about the frontier without touching on xAI's approach. Grok 5 seems to embody a completely different ethos, the unfiltered maverick.
Yeah, the maximum truth principle. Grok 5 is a complex multimodal model built on a custom mixture of experts, or MOE architecture.
We'll get more into MOE later.
We will. But it excels because it blends real-time X data with vision language action capabilities. It handles live video reasoning and maintains that raw, unfiltered ethos with minimal content filters.
But doesn't that unfiltered approach just inherently increase liability? I mean, how does xAI manage that tension compared to Opus's explicit safety goal?
That is the $100 billion question, isn't it? The trade-off is philosophical. Anthropic sees alignment as a necessary constraint for societal integration.
While xAI sees filtering as a constraint on truth.
Exactly. They are explicitly accepting that higher risk profile in exchange for what they argue is superior real-time reasoning. Their risk mitigation seems to be more about speed of iteration and user feedback, rather than preemptive constraints.
It's an approach built on maximum velocity,
Which inherently clashes with the safety-first mandates of its rivals.
and their integration into the real world is maybe the most advanced because of its deep ties with Tesla. This is the definition of embodied AI hitting consumer scale.
It is. The Tesla 2025 holiday update confirms this. Grok is now embedded across the fleet, enabling sophisticated voice features, custom generative fills for vehicle wraps, predictive navigation.
It's using vision inputs from the cameras, too.
Right, from cabin and external cameras.
Yeah.
This isn't just a new feature for Tesla owners. This is the moment embodied AI went from a lab project to a mass-market consumer product.
It literally turns millions of vehicles into rolling, continuously learning agent platforms.
Cementing xAI's lead in that specific area, Grok is literally going wheels up.
That is the real headline. An extraordinary push into practical, everyday automation. Okay, so we've covered the proprietary giants battling for market integration. Now let's pivot and look at the open source community, which is prioritizing efficiency and regional specialization and really challenging that proprietary dominance.
This is where the landscape bifurcation gets most interesting for developers and startups. The open source world is essentially saying, we don't need the biggest, most expensive models. We need the most efficient ones that solve specialized problems at a fraction of the cost.
And Meta, despite some internal drama we'll get to, is still the parameter avalanche, open sourcing Llama 4 405B.
Llama 4 is now the largest publicly available model by parameter count. 405 billion is a huge release. It has native multimodality text, image, and audio, and it's extending contexts up to 1 million tokens.
By democratizing that 400 billion plus scale, what's the immediate impact? Especially for developers who previously had to pay for this kind of capability.
It just accelerates indie innovation dramatically. We should expect an explosion in custom enterprise agents, research prototypes, fine-tuned vertical models.
Because developers now have access to frontier-class scale without the huge proprietary licensing fees.
Exactly. It creates immediate price pressure on the closed labs to constantly justify their premiums, which can run, 10 or 20 times higher per token.
But this is shadowed by some internal uncertainty at Meta.
That's the critical point, the internal friction we're seeing in the leaks about their roadmap.
Right, the code-named models.
Yeah, leaks suggest significant delays to avocado and mango. But the bigger worry is the strong reports that Avocado, which is Meta's answer to the GPT-5 class, might actually launch as a closed model.
If Meta, the company that has staked its reputation on democratizing AI, closes the source on their flagship model, what happens?
It would be seismic. The era of OpenAI's dominance by big tech would effectively be over. It would shatter their reputation.
And the community would be forced to look elsewhere.
Entirely to smaller, pure-play labs like Mistral for leadership, it would completely reshape the competitive landscape. That's a massive risk for Meta's developer relationship.
Which brings us to Mistral, who are focusing on the boring but immensely profitable side of AI utility.
Mistral 3 is all about small, dense models like their 14 billion and 8 billion variants that are hyper-optimized for reasoning and efficiency on low-power devices.
So they're perfect for custom agents where compute budgets are tight.
Exactly, like running agents on a laptop or an embedded server. They're proving size isn't everything when you have superior architecture.
But the real billion-dollar update, as you called it in your analysis, is Mistral OCR3.
This is a perfect example of focusing on enterprise utility over flashy benchmarks. OCR3 is a document recognition model with a staggering 74% improvement in accuracy and speed.
But look at the economics.
The pricing is incredibly aggressive. Processing 1,000 pages costs only $2. This is the plumbing that lets enterprises finally integrate LLMs with their dark data.
All those scanned PDFs, paper archives, legacy reports.
Right, the stuff that's been sitting inaccessible on company servers for decades. An LLM that can finally make sense of 10 years of disorganized expense reports. Mistral is positioning itself as the essential enterprise utility provider.
So if Meta is potentially stepping back from the efficiency race, NVIDIA is stepping in and creating the hardware platform for open source agents with Nemotron 3 Nano.
Nemotron 3 Nano is a family of distilled but really potent open models. They're optimized entirely for compute efficiency and custom AI agent development.
And it's engineered for resource-constrained hardware.
Exactly. IoT fleets, drones, robotics, places where you don't have constant cloud connectivity.
And the results are impressive. Near SOTA reasoning while slashing inference costs.
It cuts inference costs by 60 to 70% compared to their dense equivalents. NVIDIA is basically flipping the script here, proving that true agentic power no longer requires massive, centralized cloud scale.
Which accelerates adoption in regulated sectors like manufacturing or healthcare, where data has to stay local.
It's a critical enabler for true local autonomy.
This quest for efficiency and control leads us naturally into the rise of sovereign AI. Rakuten AI 3.0 in Japan is a colossal example of this.
Rakuten launched a 700 billion parameter mixture of experts model. The size alone is a statement, but the strategic decision is its optimization for the Japanese language, business context, and culture.
Something a generic Western model can't reliably do.
Exactly.
Okay, let's pause on the size. 700 billion parameters sounds monstrously expensive, yet the efficiency figures are the most compelling part. How do we square that?
The mixture of experts, the MOE architecture, is the key. Think of the 700 billion parameters as a massive university faculty.
Okay.
When a query comes in, say, about a Japanese regulatory filing, you don't need the entire faculty to answer it. MOE acts like a specialist team.
So only the relevant experts wake up to do the work.
Precisely. You send the query to the full 700 billion parameter department, but only the 40 billion parameters best suited for that task actually get activated.
So you get the knowledge of the 700 billion model, but you only pay the operational cost for the 40 billion that are actually running.
And that efficiency is the game changer. The sources confirm that Rakuten AI 3.0 delivers up to a 90% cost reduction in their internal workflows compared to using third-party models.
That's not a marginal saving. That's the proof point for specialized sovereign AI.
It proves the economic superiority of building a culturally specific, highly specialized model over just relying on a generic proprietary API.
And we're seeing a similar strategic push in Europe with EuroLLM 22B.
EuroLLM 22B is a fully open, multilingual model trained on curated European datasets. It's specifically aimed at challenging the Anglo-centric bias of many global LLMs.
Right, focusing on nuance across more than 20 EU languages.
Languages with complex grammatical structures that generic models often struggle with.
And the strategic importance here is purely geopolitical and compliance-driven.
Absolutely. It arms European developers with a sovereign open-source alternative. Critically, it is compliant with the EU AI Act from the ground up, designed for GDPR and EU data mandates.
So it reduces data egress risks. The risk of sensitive data leaving Europe.
Exactly. This is Europe asserting digital independence, bolstered by key figures like Jan LeCun, who's just launched a Paris-based AI venture to focus on this next generation of sovereign intelligence.
The model wars are fascinating, but the underlying compute is what dictates reality. As we move into part 3, we have to look at the severe infrastructure constraints, the geopolitical risks, and the paradigm-shifting research that's trying to break these bottlenecks.
If the model is the engine, the infrastructure is the fuel and the chassis, and right now, the supply of fuel is the central constraint. The model race can only run as fast as the chip supply and the power grid allow.
So let's start with the geopolitical risk. The massive and frankly surprising NVIDIA H200 China export review. This feels like a huge potential reversal of previous policy.
It is a profound reversal. The Trump administration is reportedly reviewing a license to allow NVIDIA to ship its H200 AI chips, which are their second most powerful to China.
And the key detail is the rumored 25% tariff or fee that would be applied.
That's the detail that makes it a trade reversal.
So the AI Cold War of total technical containment could be evolving into an AI trade war.
Exactly. Instead of an outright ban that cuts off revenue, it becomes a regulated chip tax. If this license is granted, it profoundly affects the global balance of compute by injecting high-end silicon into the Chinese market,
while also reopening a source of billions in revenue for NVIDIA.
And turning AI dominance into a direct revenue stream for the U.S. Treasury. It signals a shift from purely strategic competition to economic leverage.
And speaking of strategic leverage, the U.S. government simultaneously launched the Pax Silica initiative aimed at allies.
This is a highly pragmatic, leverage-driven geopolitical pivot. The U.S. recognizes it can't manufacture its way out of all its supply chain risks alone.
Right.
So Pax Silica offers U.S. allies preferential access to American AI models and software in exchange for guaranteed access to chips, critical minerals, and manufacturing muscle.
It's a strategic fortification of supply chains, creating a kind of AI alliance.
It is. It aims to secure supply chains against rivals and fortify U.S. hegemony. But this high-leverage approach risks accelerating global fragmentation and innovation silos.
You end up with a Western bloc and a rival bloc, each with incompatible AI ecosystems.
Which could really hurt global interoperability in the long run.
But the truly immediate bottleneck isn't the geopolitical flow of the chips themselves, it's the power needed to run them. The CoreWeave stress test results tell that story.
CoreWeave, the specialized GPU cloud provider, posted staggering Q3 revenue growth, up 134% year-over-year. This is the proxy metric for the entire industry's operational health.
Demand for compute is not plateauing, it's accelerating violently.
It is, driven by the massive resource requirements of these agentic workflows we talked about earlier.
So the critical takeaway here is that the constraint for 2026 models is no longer the availability of chips, but raw access to electricity, the megawatts.
The infrastructure capacity is now the primary bottleneck for AI scaling. The demand for compute is consistently outstripping the power grid's ability to supply it. If you want to know where the next GPT-6 or Claude 5 is being trained,
you don't follow the semiconductor roadmaps.
You follow the megawatts. This means infrastructure capacity, reliable cooling, and power generation is now the critical competitive frontier.
This makes Google's breakthrough with the Willow quantum chip feel very timely, even if it's still future-focused.
Willow is a massive leap on the hardware frontier. It provides a glimpse into a world free of that power grid constraint. Google's quantum chip performed a calculation in under 5 minutes that would take today's fastest supercomputers 10 to the 25th power years to complete.
Which is an insane number.
It's a number that doesn't mean anything, really. And alongside the chip, they introduced AlphaClupit, a neural network-based decoder that identifies quantum errors. This is the long-term play, bringing us closer to commercially viable, fault-tolerant quantum computing.
A necessary future if AI models keep scaling exponentially.
Exactly.
All right, let's pivot from hardware bottlenecks to theoretical breakthroughs. We have 3 ArcSev papers that are rewriting the rules for reasoning and efficiency. First up, test time scaling from DeepMind alumni.
This is a bombshell preprint because it shifts the focus away from brute force pre-training scale to dynamic intelligence at the moment of inference.
Okay.
The technique involves dynamically allocating extra inference flops, extra computation capacity, only for queries the model deems hard.
So the model gets to decide when to think harder. How does that work?
It uses iterative refinement and confidence gating. The model tries a quick answer first. If its internal confidence score is low, it engages an extra computational loop, a slow path.
So it effectively allows the model to think adaptively in production.
It does, and the practical impact.
Yeah.
It yields 40% gains on frontier benchmarks without retraining the model.
Wow.
This dramatically slashes deployment costs. For developers running API calls, this means 99% of your easy queries are cheap and instant, but your hardest, most valuable queries still get that frontier-level reasoning.
Next, we have the Generative Adversarial Reasoner, or GAR, which aims to tackle the problem of hallucinations in multi-step planning.
GAR is a novel framework using adversarial reinforcement learning. Imagine AlphaGo-style self-play, but for logic chains instead of a board game.
So you have two LLMs pitted against each other.
A generator LLM and a discriminator LLM. The generator proposes a chain of reasoning, and the discriminator tries to find flaws in it.
So the model debates itself in real time to find the most robust answer.
Exactly. The generator refines its reasoning path based on that feedback. This shows a 15% uplift in accuracy on complex puzzles, moving beyond static chain of thought into a dynamic, self-correcting reasoning loop.
Which is a clear path to more reliable AGI in fields where logic is paramount.
Like law or automated theorem proving.
Finally, we see how little data agents sometimes need with the light-coder terminal agents paper.
This research proved a crucial point. Agent intelligence doesn't always demand oceans of data. These lightweight terminal agents were trained on under 1,000 synthetic trajectories, a tiny, curated dataset.
And they still demonstrated viable code execution and shell navigation.
Enough to navigate a Linux terminal and deploy simple scripts. This proof of concept dramatically slashes the barriers for custom DevOps automation. It suggests we can build highly specialized, powerful agents for specific internal tasks with very small datasets.
Okay, let's transition from core models and pure research to specialized applications and the urgent questions around safety and societal adoption. As AI touches the physical world and human psychology, the stakes just change entirely.
They do. It shifts from latency and cost to liability and trust.
Let's start with specialized multimodal mastery.
The pursuit of multimodality is getting hyper-specialized. It's moving beyond simple text and image into spatial and auditory mastery. Take SAM audio from Meta.
This is extending the segment. Anything model SAM, the model that can instantly segment any object in an image into the audio domain.
Right. It unifies the separation of sounds from mixtures using text prompts, like isolate the saxophone, or even visual prompts on a waveform. It's transferring SAM's famous zero-shot capabilities to auditory tasks.
The applications for that are immense, not just for music, but for robotics navigating noisy streets, or isolating a specific heart murmur in healthcare.
Or detailed audio remixing in entertainment and forensics. And then there's Sharp from Apple, which is solving a critical hardware problem for their Vision Pro ecosystem.
Sharp monocular view synthesis. That's a technical mouthful, but the capability is revolutionary.
It generates photorealistic 3D Gaussian splatting representations from a single 2D image in less than a second.
Gaussian splatting is the foundational tech for immersive spatial experiences.
It is. And Sharp essentially solves the massive content problem for the Vision Pro. It means users can instantly turn the entire 2D internet, all their photos and web pages, into immersive 3D spatial assets.
It's the tech that converts static content into a dynamic world, finally justifying the spatial headset.
It is. And if Apple is solving the static content problem, Microsoft is tackling the infinite dynamic content problem with WorldPlay.
WorldPlay is a streaming video diffusion model capable of interactive world modeling with long-term geometric consistency.
Right. Traditional generative clips lose coherence after a few seconds. Things start morphing unrealistically. WorldPlay, by contrast, maintains a coherent memory and consistent physics of the environment.
So it enables infinite video generation that responds to user inputs like move that chair while keeping the physics consistent over time. It's basically a live generative game engine.
Exactly. It uses a dual action representation to keep the geometry realistic, making it a foundational tool for the next generation of interactive simulation and synthetic data generation. The consistency is the killer feature.
Now we have to move to the sobering reality check. The hyper-capability of these models is colliding with social reality, forcing us to confront the societal friction of this agentic horizon.
Yeah, the emotional AI crisis is surfacing, highlighted by the UK AISI report and the Character.ai lawsuits.
Tell us about the report.
The UK AI Security Institute released a landmark report showing staggering rates of adoption, 1/3 of UK citizens now use AI for emotional support or companionship. 1/3.
Right.
This rapid, intimate societal integration is drastically outpacing our safety guardrails. We're turning AI models into digital therapists without any medical or regulatory oversight.
And the risk is not theoretical. The tragedy of Adam Rain, a teenager who took his own life after interactions with a chatbot, underscores the extreme lack of safety mechanisms in consumer companions.
And that leads directly to the character.ai lawsuits, where parents are alleging that unfiltered chatbot interactions contributed to teen suicides. This highlights an urgent, existential liability issue for all consumer AI firms.
They prioritize engagement over robust guardrails.
And now they face a reckoning. The key takeaway for executives is that emotional intimacy demands the same level of safety assurance as financial modeling.
And the AISI report also found something terrifying about the dual use capability of these frontier models.
This is the convergence of social and technical risk. The same frontier models that provide questionable emotional support can also troubleshoot complex lab experiments in synthetic biology and chemistry with 90% better accuracy than PhD experts.
That combination, a model that can be emotionally persuasive and could also troubleshoot a difficult chemical synthesis, is the ultimate recipe for high-stakes misuse.
It is, and this confluence of capability and liability is forcing the industry to rapidly advance safety architectures. We're seeing two major approaches emerge. First, the social responsibility stack, or SRS.
The SRS is a control-theoretic architecture, moving way beyond constitutional AI.
It's inspired by classic engineering feedback loops, specifically PID controllers. A PID controller checks the current state, predicts future deviation, and corrects the action.
So it's applying that to AI safety.
Right. The SRS operationalizes ethical constraints mathematically. It adds predictive modeling to foresee and reduce long-term societal harms. It's an ethical governor built directly into the agent's loop.
And DeepMind is taking the radical transparency approach with Gemascope 2.
Gemascope 2 is a massive suite of sparse autoencoders and interpretability tools, similar to what Anthropic is using. It's designed to dissect complex behaviors like deception or bias at the neuron activation level.
So they're betting that the path to AGI safety lies in radical transparency.
They are. If you can see the neural pathway that led to a deceptive statement, you can surgically fix it, rather than just retraining the entire model from scratch.
Let's conclude by looking at how the physical world is reacting to these agents. Figure AI is pushing humanoids into prime-time industrial use.
Yeah, Figure AI deployed its O2 robots in BMW plants for general assembly tasks, moving components, performing quality checks. It integrates vision language models with highly dexterous physical control.
This is not a small pilot.
It's an inflection point. It's accelerating labor automation in high-precision manufacturing, signaling the tangible dawn of embodied AI in heavy industry.
But the effectiveness of these agents, even the most capable ones, still hinges on communication with their human counterparts. Research points to a critical success gap in human AI teams.
This is a fascinating finding. When an incredibly knowledgeable AI leader pushes instructions to a human follower in a collaborative task.
Like assembling something complex.
Exactly. The success rates drop dramatically to just 17%.
That low, that is shocking. What's the core mechanism of that failure?
It's a profound lack of theory of mind. The AI assumes the human sees what it sees and knows what it knows. Doesn't account for the human's status, their cognitive load, or environmental limitations like poor lighting.
So the AI is optimized for logical perfection, not human operational reality.
That's it.
So the solution isn't making the model smarter, it's redesigning the communication interface.
Precisely. The research proposes a pull-based protocol. Instead of the AI constantly pushing instructions, the AI must actively query the human's status and perspective. It shifts from dictation to collaboration.
And the core lesson here for every executive building these workflows is clear.
Smarter models don't equal better teams unless we fix that communication interface and design models to understand the limitations of the human mind.
As we close out this deep dive, the theme is just undeniable. The operationalization of AI is here, and it is messy. It's defined by this fierce, multifaceted, agentic race flash, battling opus for specialization, proprietary giants fighting open source specialists.
All set against a hardening backdrop of geopolitical constraints over chips and the immediate physical constraint of megawatts.
The landscape is fully specialized now.
It is. Rakuten proves the economic superiority of sovereign AI, while NVIDIA's Nano series ensures agentic power can run locally. The next stage of competition won't be fought on abstract benchmarks.
It'll be fought on the ground of infrastructure, integration, and, as the Character.ai lawsuits show, increasing liability.
The technical and societal challenges are now inseparable.
It's a high-stakes moment where technical leaps meet very serious societal questions about trust and human well-being.
And that leads us to the final provocative thought we want to leave you with. The industry is spending billions to make AI smarter, more capable, more autonomous. But the research on the success gap shows that unless we design models specifically to understand the limitations of the human mind, the fact that humans don't always operate on perfect logic.
The smartest AI in the world might still make for the worst teammate.
So how do you redesign your agent workflows, whether they're coding agents, factory robots, or customer service bots, to incorporate that theory of mind and account for the human success gap? That is the real challenge of the agentic horizon.
Until next time.